The other commonly used statistical distribution is known as the student's t-distribution. William Seeley Gossett specified the t-distribution. In fact, he published a paper in Biometrica in 1908, and he published it under the pseudonym Student. He worked for the Guinness Brewery in Durban, Ireland, where he worked with small samples of barley. Mr. Gossett is the unsung hero of statistics. He published his work under a pseudonym because of the restrictions from his employer. Apart from his published work, his other contributions to statistical analysis are equally significant. The Cult of Statistical Significance, a must-read book for anyone interested in data science, chronicles Mr. Gossett's work and how other influential statisticians of the time, namely Ronald Fisher and Egon Pearson, by way of their academic bona fides, ended up being more influential than the equally deserving Mr. Gossett. The normal distribution describes the mean for a population, whereas the t-distribution describes the mean of samples drawn from a population. The t-distribution for each sample could be different, and the t-distribution resembles the normal distribution for large sample sizes. Here, I present normal distribution, which is drawn in blue, and the t-distribution with a degree of freedom of 1. As the degrees of freedom increase, the t-distribution curve becomes more similar to the normal distribution. In statistical analysis, several statistical tests rely on t-distribution. For instance, a comparison of means test used the t-distribution and is also known as the t-test. We have been working with a dataset comprising teaching evaluations of instructors from University of Texas. And I will illustrate the use of t-test or t-distribution with the question of, does instructor evaluation score differ by gender? Do males and females get different teaching evaluations from students? Now, if I were to take the same data set and compute the means and standard deviations, I can test this statistically. So using SPSS, I have computed the average teaching evaluation score for males and females. This bar represents the values for females, and this bar represents the average teaching evaluation for males, which looks like it's around 4, and I'm eyeballing it, and for females it's slightly less. Now, it's a small difference between males and females. The question is this difference statistically significant? I have used SPSS to compute some basic descriptive statistics and then ran the independent samples t-test. For teaching evaluations for female instructors, there were 195 courses taught by females and about 268 courses taught by males. The average teaching evaluation was 3.9 for females and 4.06 for males. And the standard deviation was 0.53 for females and 0.55 for males. And the question is this difference in average teaching evaluation statistically significant? We ran the independent samples t-test and we found that the t value is minus 3.25, which is above the threshold of 1.96 or negative 1.96, and therefore we conclude that this minute difference between males and females teaching evaluations is in fact statistically significant. So it's a t-distribution allowing us to make this conclusion.